This is video 2.7. It actually is 2.7a. I divided 2.7 into two separate sections. It is all about percent composition. So by the end of this video, you should be able to calculate the percent composition of an element in a compound. Just a little background. I know you've all seen one of these nutrition fact things, but it tells you just how much of all these different things are in each food that you eat. Um, the percent daily value is the percent of corresponding to how much this food contributes to your overall daily nutritional requirements. Um, so, super important to know these things, especially if you're keeping track of being healthy. Um, and they calculate this the same way we calculate percent composition in a compound or a mixture in chemistry. So, the equation for percent composition, which you will need to know, is the part of the mass divided by the total mass times 100. Just like with any percent of your grade on a test. The part you got right divided by the total number of questions times 100 gives you your grade. So percent always works the same way. Part divided by the whole times 100. This is no different. So, a quick example says find the percent by mass of hydrogen in phosphoric acid. So, the chemical formula for phosphoric acid is this H3PO4. So, there are 3 hydrogens, 1 phosphorus, 4 oxygens. So, we need to find the percent mass of hydrogen. So, the first thing that we need to do, this is written out kind of weird, but I'll try to explain it as we go. These numbers right here come from the periodic table. So we are finding the molar mass of first hydrogen, because that's the part that I'm looking for. The molar mass of hydrogen is 1, and there are 3 of them. See, H3, 3 times 1. Then this is the mass of the whole thing. So the hydrogen, the phosphorus, and the oxygen. So we have 3 times 1 for the hydrogen plus 32.1. If you look at phosphorus on a periodic table, that's its mass. And then 4, for this 4 right here, times 16 for oxygen. So we have the mass of the hydrogen divided by the mass of the total compound times 100 to give us a percent. When you calculate that all out, you get 3.02%. So there's 3% of phosphoric acid is made up of hydrogen. The other 96.98% is made up of the phosphorus and the oxygen. But that 3.02% is from the hydrogen. Let's try another example here. This time I have calcium oxide, calcium, oxygen, hydrogen. Remember these parentheses with the 2 on the outside means that there's 2 oxygens, 2 hydrogens. So 1 calcium, 2 oxygens, 2 hydrogens. And what we're looking for is the percent of calcium in this whole thing. So I look up calcium on the periodic table. 40 is its molar mass. And then I find the molar mass of the whole compound. 40 plus 2 times 16, because remember there's 2 oxygens, plus 2 times 1 for the hydrogens. Then to make it a percent, I multiply it times 100. I work that all out. I get 54.1%. So 54.1% of calcium oxide is made up of calcium. So a little more than half of this compound is calcium. Take a minute and pause the video and try these 3. So find the percent of sodium in each of these. Here we have sodium, chlorine, and oxygen, just sodium chloride, and this is sodium hydroxide. So if we look at the first one, the molar mass of sodium is 23. The molar mass of the whole compound is 74.5. Multiply that times 100, and we get 30.9%. Before I move on, do you think the sodium percent will be higher or lower in this one? Have the sodium, have the chlorine. This one's just missing the oxygen. What do you think? All right, let's find out. So the sodium is 23%. This whole compound, or 23 grams, sorry, the whole compound is 58.5 grams. Multiply that times 100%, and we get 39.3%. So sodium makes up more of this compound than it does of this one. It's 39% of this compound and just under 31% here. That's because the oxygen takes up some space as well. Now let's do the sodium hydroxide. 23 from the sodium, 40 is the sodium plus the oxygen plus the hydrogen. Multiply that times 100, 57.5%. So 57.5% of this compound is made up of the sodium. So way over half of it. All right, now let's try another example here that's kind of written out. It says a sample of a substance containing only magnesium and chlorine was tested in the laboratory and found to be composed of 74.5% chlorine by mass. If the total mass of the sample was 192 grams, what is the mass of the magnesium? So 75% of it is chlorine, or 74.5, which means that 25.5% of it is magnesium. If we work out this problem, 0.745, that's the percent written as a decimal, times the total mass is 141.7 grams. So 141.7 grams of this 190 grams is chlorine. And then we can subtract to get the magnesium, which isn't on here. I should write it down. So we would do 190.2 minus 141.7, and that equals what? I can't think of it. 48. I don't have a calculator right now. 0.5? I don't know. Do it with your calculator. See how close I am. So 48.5 grams of this sample is magnesium because 141.7 grams of it is the chlorine. So those are some examples of calculating percent composition. If you just remember the formula, you should have no problem with it.